All right, these are notes for 3.6. After this, there's just, after chapter 3 or unit 3, there's one more small unit and then a final exam, and then the content for this is over. So our question in 3.6 is going to be, how do we add? So we did multiplication, we did division. Now it's going to be, how do we add and subtract? But we're going to keep this one fairly easy because we're going to say with like denominators. And if the denominators are the same, let's go ahead and write that down. Can't quite fit it on that whole line there. If the denominators are the same, it makes fractions kind of easy. And let's go back and review why from elementary school when we didn't have any variables in it. If I just had 1/6 plus, let's say, 5/6, I just keep the bottom, add the top, and then reduce when I'm done. And that process, no matter how ugly your fractions get, if you notice the denominator's the same, I don't care what it is, maybe it's 4x squared plus 9x minus 12, but if it's the same on both of them, you simply keep it and then add or subtract the tops based on whatever's indicated in the middle. So, and then we reduce when we're done. So that's exactly how we're going to approach the algebraic fractions. If I have 3 over 5x, and then I have 4 over 5x, and then I add to it 10 over 5x. The first thing you do when you're looking at fractions is note that you are not multiplying, you're adding. Addition requires a common denominator, but for today you're going to have one. So if you have a common denominator, you keep it, and then you add up the tops. 3 plus 4 is 7. 7 plus 10 is 17, and I get 17 over 5x. And 17 and 5 don't share any factors, so that's done. If I'd had 15 over 5x, I'd have to reduce it more when I was done with it. So all we're going to do is just start making those denominators a little uglier. But other than that, this section's fairly easy, but keep in mind, when we change these denominators so that they're different, it's going to get a little tricky. But for now, we are adding. We're immediately going to go look at the denominator. And we're going to notice that they're the same. So what I do is I keep it, and I add up the top. The top is an x plus 3 plus a 6x plus an 11. When I add those tops up, I get 1x plus 6 more x's gives me 7 x's. I'm combining like terms right now, and 3 plus 11 gives me 14. You might be dying to cancel those 7's, but again, you can't, because when you see that plus sign there, you have to factor first. So before I can cancel that 7 out, I have to yank it out or divide it out of both terms on the top of that fraction. There's your 7x plus 14 with the 7 factored out of it. And this is over 7. All right, now these 7's cancel and you get x plus 2. And we're done. Next example, we're just going to do 2 more. On the next one, we have an x squared on the top, and I'm going to put an x minus 5 on the bottom. Then I'm going to go do minus 25 over x minus 5. And again, I'm going to notice that I've got the exact same denominator. So with addition and subtraction, we need a common denominator, but once we have one, which we do, we keep it and we subtract the tops. We don't cancel anything because of that subtraction. You might be tempted to think it's done, but we've got an oldie but a goodie right here on the top. Remember, this kind right here is called a difference of squares. And I can factor that by putting an x in front. X times x is x squared. 5 times 5 is 25. And to create a canceling in the middle and that minus sign, I choose 1 plus and 1 minus. I feel like I'm doing it right because I'm getting cancellation at the end. So the answer, the simplified answer, is x plus 5. And you might say, why would I ever want to do that? Here's why. If I were to just give you this one and say, what's the answer when x is 10? You'd have to go put in a 10 and square it, put in a 10, put in a 10, subtract it, clean it up. Where in the simplified version, I can just say, well, when x is 10, the answer is 15. These two things are equal. This is just considered in a simpler form, and it makes it easier to work with. So the last one up is going to be x, I'm just making the denominators uglier, over x squared plus 3x minus 10, and that's plus 5 over x squared plus 3x minus 10. So what I've got on the bottom is the same denominator, so I keep it. Doesn't matter that it's getting uglier, it's still the same here as it is over here. So once I get that same denominator, I go to the tops and I do exactly what it says. I add them up and I call it x plus 5. So I've got an x plus 5 on the top, and on the bottom, nothing comes out of these terms. It's not a difference of squares, but it's easily factorable because 5 and 2, when 2 is negative, multiply to equal a negative 10 and add up to 3. So this should be plus 5 and this should be minus 2. Now these cancel. Be careful when the entire top cancels because you do need to put a 1 on there. You can't just say nothing over x minus 2. It's a 1. So that one's done. Your task now is to go grab worksheet number 9. It's gray. And you're going to work on that. When I OK that, you're going to grab worksheet number 10. It's bright gold, and you're going to work on that one. So this lesson has 2 worksheets that go with it. Gray first, then no more notes, and then gold. Okay, and then one more section of notes before we start getting ready for a test. All we're going to do is make those denominators different. Makes it quite a bit harder when I do that, though. Peace out.